Good morning. We are going to be looking at how to find the area of a triangle that is not a right triangle. Now, if you remember from your geometry class or your early on middle school class, the formula for finding the area of a right triangle is 1/2 base times height. Well, the first formula that we're actually going to take a look at is very similar. The area formula is 1/2 AB sine C, or 1/2 BC sine A, or AC sine B. It all depends upon what the given information is for the particular triangle that you are looking at. AB here represents the side lengths of angle or sides A and B, whereas C is the angle that is given between A and B. BC, those are side lengths as well, and angle A will be the angle that is between those two sides. And AC, again, side lengths, and angle B being side B. Just as it was important in your geometry class, it's extremely important right now for your calculator to be in degree mode. We're not in radian mode for this portion of the unit. All right, so our first example, we will have a triangle here. We have C, we have A, we have B. And we're given that angle C is 25 degrees. Then we have side AC here, which is 10, and side CB here, which is 7. Okay, so what's really being given here, angle C, this would be side length C that he's not given. The angle A, across from him, is our side length of A. B's angle is here, and across from him is a side length of B. Whenever you are given basically a side angle side triangle, you're going to use our law of sines formula. Now, for example, if you're not given the information that you need to complete this portion, you can, of course, jump into finding missing side pieces, which is, again, law of cosines or law of sines, which is in a different video. All right, so here we go. Area equals. In this case, we're given side angle C, so we're going to use our first one, where we're going to use A and B. So area is equal to 1/2 7 times 10 times sine of angle 25 degrees. All right, and the rest of this is just going to be basically plugging in. 7 times 10 is 35. 7 times 10 is 70, and half of 70 is 35. So we now have 35 times sine of 25. Now, of course, you're going to have to approximate your decimal here. You're going to type in sine of 25 into your calculator. And the decimal value of this multiplied by 35 gives you approximately 14.8. Now, I didn't give you what type of units was being used for this area, so I can simply say units, an area is squared. All right, so we're going to look at another area formula, again, for triangles that are not right triangles. This one in particular is called Heron's formula. Now, previously to this, we did law of sines, okay? This one's Heron's formula. And Heron's formula is typically used if you know all your side lengths. So you have a side, okay? The first thing you need to do when using Heron's formula, because you have all your sides are given to you, is calculate what is called the semi-perimeter. Now, semi-perimeter is exactly as it sounds. You're going to take the perimeter, A plus B plus C. Those are all your side lengths. Semi is actually a root stem word for the word half. So you're going to take half of your perimeter. This is going to be my value for S. Take your perimeter and cut it in half. The next part is actually just plugging it into Heron's formula itself. So area is equal to the square root of this giant expression I'm about to write. The semi-perimeter times the semi-perimeter minus side length A times the semi-perimeter minus side length B times the semi-perimeter minus side length C. And that is Heron's formula. S represents semi-perimeter, And A, B, and C all represent side lengths. So let's do an example. Your example is, you're given an equilateral triangle. Now, equilateral triangle means all your sides are the same length. So that's just a note to put in your head. You're given an equilateral triangle with side length of 5. Now, if you hadn't remembered your geometry, you wouldn't recognize the fact that A, B, and C are all 5. Okay? So we have equilateral triangle, side lengths are all 5. There's my little picture for myself. My first step is calculating my semi-perimeter, S. So I know 8 plus B plus C, 5 plus 5 plus 5, all over 2. 5 plus 5 plus 5 is 15. Cut that in half, and you get a semi-perimeter of 7.5. The next thing that I need to do is to plug it into Heron's formula. A equals the square root. So I know I have my semi-perimeter times the quantity, 7.5 minus 5. And again, 7.5 minus 5. And one more time, 7.5 minus 5. Now, for equilateral triangles, obviously all these quantities are going to be the same because once again, A, B, and C are all the same side lengths of 5. So I'm going to do a little bit of math here. I know 7.5 minus 5. That's always going to give me 2.5 for all of these quantities. So I really have whatever 7.5 times 2.5 times 2.5 times 2.5 is. And this ends up becoming the square root of 117.18. Again, you're going to start to round. It's going to be a little bit different than what maybe I have. When I take the square root of this quantity, I get approximately